Good afternoon, students. Today we will discuss a few more concepts related to work. Right. So in the last class, we stated the statement work done. That is, W is equals to Fs cos theta. So force component in the direction of the displacement, we call that one as work done. Right. So next, work done in rectangular components. So rectangular means in a coordinate system we are going to discuss about the work done. So last class and now discuss what we do only in one direction. So ಯಾವುದೋ ಒಂದು object ಇರುತ್ತೆ force apply ಮಾಡ್ತಾ ಇದ್ರೆ object gets displaced, right? So that is the work done. W is equals to F into S, right? So ಇದು only in one direction, that is along the x-axis, right? So here in rectangular components means we need to take all the three axes, right? So x-axis, y-axis, and z-axis, right? So now consider one object. Initially, the position of the object is at origin. So origin means here, if we consider O, so the position is 0, 0, 0. So x coordinate, y coordinate, and z coordinate. So S0 to 0. So that's the object is at origin, right? So now apply the constant force to this object, right? So one constant force now apply ಮಾಡ್ತಾ ಇದೀವಿ. So you can take in any direction, right? So force apply ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ object ಏನಾಗುತ್ತೆ, it changes its position. So it will come somewhere here, right? Force here. Now P be the position of the object after it displaces from its initial position. So initial position ellide, origin allide. So force apply madidre it changes its position to somewhere. We taken that point as P, right? So that is x comma y comma z, right? So along x-axis is right, only we can take x. So in xy plane is xy. So here in space we are considering so x, y, and z, right? So the displacement from here to here we take that one as yes. So ಇಲ್ಲಿ force apply ಆಗ್ತಾ ಇದೆ, force ಜೊತೆಗೆ position ಕೂಡ ಏನಾಗಿದೆ change ಆಗಿದೆ object. So initially ಎಲ್ಲಿದೆ ನಮಗೆ origin ಅಲ್ಲಿದೆ. So force apply ಮಾಡಿದ್ಮೇಲೆ it changes its position to x, y, z, right? So the applied force in space F, that is equals to, so force is a vector in 3 dimension or in the space, we can represent that one as Fx I cap plus Fy j cap plus Fz k cap, right? So this is the force along the x-axis, force along y-axis, and force along z-axis, right? So displacement agide, displacement ellagide namage space allagide, right? So again displacement S is also a vector, right? So x I cap plus y j cap plus z k cap. So magnitude, direction, magnitude, direction, magnitude, and direction. So x is the magnitude along x-axis, y is the magnitude along y-axis, z is the magnitude along z-axis, right? So here we need to find the work done in rectangular components. So we know the formula work done, W is equals to F dot S. So it is a product of two vectors, so that is the dot product, or we call this one as the scalar product, right? So substituting the values of F and S. So Fx I cap plus Fy j cap plus Fz k cap dot again x I cap plus y j cap plus z k cap. So again by applying the rules, so I'm ಗೊತ್ತಿದೆ dot product ಅಲ್ಲಿ multiply ಮಾಡಿದ್ರೆ finally we get the work done, that is in the scalar, right? So W is equals to Fx I cap into x I cap, so we get Fx suffix into x. So I cap dot I cap, the value is 1. So ಇದನ್ನ ನಾವು ಆಲ್ರೆಡಿ ವೆಕ್ಟರ್ಸ್ ಅಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡಿರೋದ್ರಿಂದ I cap dot I cap value ಏನಿರುತ್ತೆ ನಮಗೆ 1. So 1 into Fx into x, again we get fx x, right? So next fx into y, so here I dot j, that is again from the property I dot j is equals to 0. So if we multiply these two terms with I cap, we getting the 0, right? So directly we can write fx x plus fy y plus fz z. So this is the work done in rectangular components. So where fx is the force which is applied along the x-axis, fy is the force along the y-axis, and fz is the force along the z-axis. And x is the displacement along x-axis, y is the displacement along y-axis, and z is the displacement along z-axis. Right. So this is the work done in rectangular coordinate system. So if it is in a plane, so now work done in planally considered model, right? So plane means either you can take any two axes, right? So x-axis, y-axis, right? So initially the object is at origin, so it displaces to some point P of x comma y, right? So this displacement is what? Yes, we taken that as the displacement, and F is the force. So in any run z-axis irola, so work done W is equals to fx x plus fy y. So this is in plane. This is in space. So in space, work done ಅಂತ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, so three coordinate system ಕೂಡ ಯೂಸ್ ಮಾಡ್ಕೊಂತಾ ಇದೀವಿ, x y z. So in plane ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡ್ರೆ only two coordinate system, x and y, right? So by using this, we have one problem. Find the angle between the force they given 3 I cap plus 4 J cap minus 5 K cap units and displacement is that is equals to 5 I cap plus 4 J cap plus 3 K cap units, right? So here we need to find the angle between the force and displacement, right? So again this is related to the rectangular components, right? So we know work done W, that is equals to F dot S, right? So work done is equals to F dot S, and also we know the definition of the dot product. F dot S, we define that one as it is the magnitude of the product of two vectors and cosine of the angle between the two vectors, where theta is the angle between the force and displacement. So here we need to find the theta. So now we calculate ಮಾಡಬೇಕು, theta calculate ಮಾಡಬೇಕು, right? So F into S, here we have the relation work done, that is F dot S. So F dot S na ಏನು ಬರೆಯಬಹುದು, Fx into x. So x component 3 into 5 plus 4 into 4, that is plus of minus 5 into 3, we get F dot S. So next we need to find the individually the magnitude of force and magnitude of the displacement, right? So ಈ ಎರಡು values find out ಮಾಡಿದ್ರೆ ನಮಗೆ ಏನು ಬರುತ್ತೆ, theta value ಬರುತ್ತೆ, right? So first find F dot S. So F dot S is equals to 3 I cap plus 4 J cap minus 5 K cap dot 5 I cap plus 4 J cap plus 3 K cap, right? So multiplying these two, so 3 into 5 plus 4 into 4 plus minus 5 into 3, right? So 15 plus 16 minus 15. So minus 15 plus 15 get cancelled. We get F dot S, that is equals to 16, right? So ಇದು ಏನು ಬಂತು ನಮಗೆ LHS value ಬಂದಿದೆ 16. Now to find the magnitude of force and magnitude of the displacement. So again by the vectors magnitude of force, how to find the magnitude of force, that is equals to under square root of x square plus y square plus z square. So here x is nothing but force. So force ತಗೊಂಡಿರೋದ್ರಿಂದ fx, fy, fz, right? So that is fx square plus fy square plus fz square, right? So under square root of 3 square plus 4 square plus of minus 5 whole square, right? So square root of 9 plus 16 plus 25, right? So 16 plus 9, 25, 25 plus 25, 50. That is root 50. So this gives what? The magnitude of force. Similarly, we need to find the magnitude of the displacement. Again, under square root of x square plus y square plus z square, right? So under square root of x square value is 5 square plus y value is 4 square plus z value is 3 square, right? So square root of 25 plus 16 plus 9. Again 16 plus 5, sorry, 16 plus 9, 25. So 25 plus 25 we get that one as 50, right? So ಇವಾಗ ನಮಗೆ ಎಲ್ಲ ವ್ಯಾಲ್ಯೂ ಸಿಕ್ತು. ಒಂದು f dot s ವ್ಯಾಲ್ಯೂ ಸಿಕ್ಕಿದೆ. ನೆಕ್ಸ್ಟ್ f and s. So substitute in the formula, right? F dot s is equals to fs cos theta. So f dot s value is 16. That is equals to f value is root 50 into root 50 cos theta, right? So 16 is equals to root 50 into root 50. We can write that one as 50 cos theta. So cos theta is equals to 16 divided by 50. So this becomes 1.6 by 5 and this becomes 0.3. Right? So 1.6 by 5 we get 0.32. So theta is equals to cos inverse of 0.32. Again by using the cos table. So table will use body find model we get the value of theta approximately that is 71 degree. So this is the angle between the force and displacement, right? So ಈ ತರ ಪ್ರಾಬ್ಲಮ್ಸ್ 2 ಮಾರ್ಕ್ಸ್ ಗೆ ಕೇಳ್ತಾ ಇರ್ತಾರೆ. Find the angle between or so angle ಕೊಟ್ಟಿರ್ತಾರೆ, you need to find the force or displacement. So ಇದರಲ್ಲೇ rearrange ಮಾಡ್ತಾ ಇರ್ತಾರೆ. So this is rectangular components. So it's similar to that of the dot product. So dot product ಅಲ್ಲಿ ನಾವು a dot b ಅಂತ ತಗೊಂಡಿದ್ವಿ, ಇಲ್ಲಿ f dot s. So as is ಉಳಿದಿದೆಲ್ಲ same. So next, nature of work. So nature of work means ನಮಗೆ ವರ್ಕ್ ಪಾಸಿಟಿವ್ ಇರುತ್ತೋ ನೆಗೆಟಿವ್ ಇರುತ್ತೋ ಆರ್ ಝೀರೋ ಇರುತ್ತೋ ಅಂತ ಹೇಳೋದನ್ನ ನಾವೇನಂತ ಕರೀತಿದೀವಿ ನೇಚರ್ ಆಫ್ ವರ್ಕ್. ಅಗೇನ್ ಬೈ ಯೂಸಿಂಗ್ ದ ರಿಲೇಷನ್. ಸೊ ನಾವು ಯಾವುದೇ ವರ್ಕ್ ಪಾಸಿಟಿವ್ ಇದೆ ಅಥವಾ ನೆಗೆಟಿವ್ ಇದೆ ಅಂತ ಹೇಳಬೇಕು ಅಂದ್ರೆ ಅಗೇನ್ ಬೈ ಯೂಸಿಂಗ್ ದ ರಿಲೇಷನ್ W is equals to Fs cos theta. By using this relation only we can say that work is either positive or negative or it may be zero, right? So the first case positive. So when we say that the work is positive, right? So ನಮಗೆ force ಮತ್ತೆ displacement ನ ನಾವು constant values ಅಂತ ತಗೊಂಡ್ರೆ so certain force apply ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ it displaces some amount. So ಸ್ವಲ್ಪ amount ಅಲ್ಲಿ ಅದೇನಾಗುತ್ತೆ displace ಆಗ್ತಾ ಇದೆ. So ಇಲ್ಲಿ ನಾವೇನ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಾಗಿರೋದು work positive or negative. So that completely depends on the value of cos theta. So cos theta value ಮೇಲೆ ನಮಗೆ work positive, that means ವರ್ಕ್ ವ್ಯಾಲ್ಯೂ ಪಾಸಿಟಿವ್ ಅಲ್ಲಿ ಬಂದ್ರೆ ಅದನ್ನ ಪಾಸಿಟಿವ್ ವರ್ಕ್ ಅಂತ ಕರಿತೀವಿ, ವರ್ಕ್ ವ್ಯಾಲ್ಯೂ ನೆಗೆಟಿವ್ ಅಲ್ಲಿ ಬಂದ್ರೆ ಅದನ್ನ ನೆಗೆಟಿವ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ದಿಸ್ ವರ್ಕ್ ವಿ ಕ್ಯಾನ್ ಸ್ಟೇಟ್ ಬೇಸ್ಡ್ ಆನ್ ದಿಸ್ ಆಂಗಲ್ theta, right? So that angle which is lies between 0 degree less than or equal to theta or less than or equal to 90 degree, right? So ನಮಗೆ theta value lies in between 0 degree and 90 degree to andre, so that case we call that one as the positive work, right? So previous class ಅಲ್ಲಿ ನಾನು explain ಮಾಡಿದ್ದನ್ನ ಕಾನ್ಸೆಪ್ಟ್ ತಗೊಂಡ್ರೆ, right? So here I am applying the force F, right? So this force makes an angle theta with the horizontal, right? If we take this one as vertical. So this component is F cos theta. So this force which is lies in between the 0 degree and 90 degree, right? So horizontal means along x-axis, vertical. So quadrant observe ಮಾಡಿದ್ರೆ ನಮಗೆ force ಏನಿದೆ in between 0 and 90 degree ಇದೆ. So in this case we call that one as the work is positive, right? So or if we take one more example, right, when we pull or push an object by a force, constant force. So ಇಲ್ಲಿ ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, I am pushing object with some constant force, so it displaces by some value. So initially it's I and final position is XL. So this displacement is what? Yes, right? So force ಈ ಕಡೆಗೆ act ಆಗ್ತಾ ಇದೆ, that means I am pushing the object and also displacement is takes place in the direction of force. So displacement ಕೂಡ ಏನಿದೆ ನಮಗೆ vector, right? So displacement takes place in the direction of the applied force, that means force and displacement both are parallel. So force ಕೂಡ vector ಇದೆ ನಮಗೆ, displacement ಕೂಡ vector ಇದೆ. So that means these two are parallel. So parallel means angle between the force and displacement theta is equal to what? 0 degree, right? So when theta is equal to 0 degree, work done W is equal to Fs cos 0. So cos 0 value is 1. 1 into Fs is work done is equal to Fs. So we call this work as maximum work. So ನಮಗೆ maximum work ಯಾವಾಗ ಆಗುತ್ತೆ ಅಂತ ಹೇಳ್ತಿದೀವಿ, when force and displacement both are in the same direction. Both are in the same direction, nothing but these two are parallel. So force ಮತ್ತೆ displacement ಎರಡು ಏನಿರಬೇಕು ನಮಗೆ parallel ಇರಬೇಕು. So that case we call that one as maximum work. So ಇಲ್ಲಿ work ಆಗ್ತಿದೆ, ಆ work ನ ಏನಂತ ಕರೀತೀವಿ, maximum, and here we getting the positive value, right? So hence we call that one as positive work, right? So one example for this is pushing or pulling an object. So now push ಮಾಡ್ತಾ ಇದೀವಿ ಅಥವಾ pull ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ, so that work done we call as a positive work, right? So if we take one more example, so consider one spring which is attached to the block, right? So one spring is there. So ಈ spring ನ ನಾವು ಏನು ಮಾಡ್ತಾ ಇದೀವಿ, one block ಗೆ attach ಮಾಡಿದೀವಿ, right? So now I am pulling this block with some constant force. So some force ಇಂದ ಏನು ಮಾಡ್ತಾ ಇದೀನಿ, ಈ block ನ pull ಮಾಡ್ತಾ ಇದೀನಿ. So pull ಮಾಡ್ತಿದೀನಿ ಅಂದ್ರೆ object ಏನಾಗುತ್ತೆ ನಮಗೆ displace ಆಗುತ್ತೆ along with the spring, right? So this becomes the initial position and this becomes the final position. So that means displacement takes place in the direction of pulling the object. So object na pull ಮಾಡ್ತಾ ಇದೀನಿ ಅಂದ್ರೆ in the direction ಅಲ್ಲಿ ಏನಾಗ್ತಿದೆ ನಮಗೆ displace ಆಗ್ತಿದೆ, right? So that means the force exerted to pull the object. So here we getting the work, so that work is positive work, right? So ನಾವು ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಆಬ್ಜೆಕ್ಟ್ ನ ಪುಲ್ ಮಾಡ್ತಾ ಇದೀವೋ, ಸೊ ಇನ್ ದ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಅಂತ ವರ್ಕ್ ನ ನಾವೇನಂತ ಕರಿತೀವಿ, ಪಾಸಿಟಿವ್ ವರ್ಕ್. ಇಫ್ ವಿ ಪುಷ್ ದ ಆಬ್ಜೆಕ್ಟ್, ಸೊ ಇದನ್ನ ಪುಷ್ ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ ಸ್ಪ್ರಿಂಗ್ ಏನಾಗುತ್ತೆ, ಕಂಪ್ರೆಸ್ ಆಗುತ್ತೆ. ಸೊ ಕಂಪ್ರೆಸ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿರೋ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಆಗ್ತಿದೆ. ಸೊ ದಟ್ ಮೀನ್ಸ್ ಹಿಯರ್ ಆಲ್ಸೋ ವಿ ಸೇ ದಟ್ ಒನ್ ಆಸ್ ಪಾಸಿಟಿವ್ ವರ್ಕ್, right? So these are the two examples for the positive work. When work is positive means the angle theta lies in between 0 degree and 90 degree, then those works are called as positive work. When work is maximum, when theta is equals to 90 degree, we get the work maximum, right? So that is Fs. Cos 0 is 1, so 1 into Fs is Fs, right? So this is the positive work, right? So next, second one is negative work. So for negative work, theta ranges between 90 degree less than theta or equal to 180 degree, right? So theta value namge in between 90 degree and 180 degree ittu andre, so that work we call as negative work, right? So again by considering the same example, So ಒಂದು object ತಗೊಂಡಿದ್ವಿ, we are applying some force to push this object or pull this object. So all force apply ಮಾಡಿರೋ force ಗೆ ವರ್ಕ್ ಏನಿರುತ್ತೆ ಪಾಸಿಟಿವ್ ಇರುತ್ತೆ. ಸೊ ನಾವು ಪುಷ್ ಮಾಡ್ತಿದೀವಿ, ಯಾವುದಾದ್ರೂ ಒಂದು ಸರ್ಫೇಸ್ ಇನ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಇದೆ ಅಂದ್ರೆ there is a friction, right? So generally we take kinetic friction Fk. That means frictional force by the block. So frictional force ಯಾವ್ದ್ರಿಂದ ಬರ್ತಿದೆ, ಬ್ಲಾಕ್ ಇಂದ ಬರ್ತಿದೆ. So work done by the frictional force is negative. That means so force apply ಈ ಕಡೆ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಆಗ್ತಿದೆ ಅಂದ್ರೆ displacement is in this direction, right? So the frictional force is opposite to that of the displacement. So displacement positive x axis ಅಲ್ಲಿ ಇತ್ತು ಅಂದ್ರೆ frictional force ಏನಿದೆ ನಮಗೆ negative x axis. That means angle. So this is the displacement x and here is the frictional force Fk, right? So these two are anti-parallel vectors. So anti-parallel vectors means angle theta is 180 degree, right? So ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ angle ನ ಮೆಜರ್ ಮಾಡಿದ್ರೆ ಎಷ್ಟು ಇರುತ್ತೆ ನಮಗೆ 180 degree ಇರುತ್ತೆ, right? So theta is 180 degree. So substitute that in the formula. W is equals to Fx cos 180 degree. So cos 180 is minus 1. So we getting minus Fx. Right? So in this case we are getting work done minus, hence we call that one as negative work. So best example for this is work done by the frictional force so work done by the frictional force ಯಾವಾಗಲೂ ಏನಿರುತ್ತೆ ನಮಗೆ ನೆಗೆಟಿವ್ ಇರುತ್ತೆ, right? So ಇಲ್ಲಿ ಕೂಡ ಅಷ್ಟೇ ಸೇಮ್ ಎಕ್ಸಾಂಪಲ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ so now object of pull ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ so there is some force which is restored in the spring, so that force we call as the restoring force. So restoring force is always opposite to the direction of the applied force. So applied force ಈ direction ಅಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ restoring force ಯಾವ direction ಅಲ್ಲಿ ಇರುತ್ತೆ, that is opposite to that of the applied force. We call that one as Fr. So restoring force opposite to that of the force means so ಈ ನಮಗೆ restoring force ಇತ್ತು ಅಂದ್ರೆ displacement opposite ಅಲ್ಲಿ ಆಗ್ತಿರೋದ್ರಿಂದ here also we are getting the angle 180 degree, right? So 180 ಬರ್ತಿದೆ ಅಂದ್ರೆ again work done is equals to minus Fs. So this work we call as minimum work. So minimum work ಅಂತ ಯಾವಾಗ ಕರೀತಿದೀವಿ ನಮಗೆ when these two are anti parallel, right? Force ಮತ್ತೆ displacement ಎರಡು anti parallel ಇತ್ತು ಅಂದ್ರೆ so force and displacement both are anti-parallel, right? So then that type of force, that type of work we call as negative work. So example, work done by the restoring force in the spring, right? So these are the two examples for the negative work, right? So positive work ಇರಬೇಕು ಅಂದ್ರೆ force ಮತ್ತೆ displacement parallel ಇರಬೇಕು. So negative work ಇರಬೇಕು ಅಂದ್ರೆ force ಮತ್ತೆ displacement anti parallel ಇರಬೇಕು, angle 180 degree ಇರುತ್ತೆ. So ಇಲ್ಲಿ ಬರುವಂತ ವರ್ಕ್ ನ ನಾವು ಏನಂತ ಕರೀತೀವಿ, minimum work. So parallel ಅಲ್ಲಿ ಇತ್ತು ಅಂದ್ರೆ ನಮಗೆ ಬರೋ ವರ್ಕ್ ನ ನಾವು ಏನಂತ ಕರೀತೀವಿ, maximum work, right? So maximum then minimum. So director ಕೇಳಬಹುದು ನಿಮಗೆ write the maximum and minimum work, write the condition for maximum and minimum work means you need to mention this point, theta is equals to 0 degree or the force and displacement are parallel. In case negative work means you need to mention theta is equals to 180 degree or anti parallel, right? So the last one is zero work. So again by using the same relation W is equals to Fs cos theta. So ಇಲ್ಲಿ ನಮಗೆ 0 ವರ್ಕ್ ಅಂದ್ರೆ ವರ್ಕ್ ಏನಿರಬೇಕು ನಮಗೆ 0 ಬರಬೇಕು, right? So right side of the equation ಏನಿರಬೇಕು ನಮಗೆ 0 ಇರಬೇಕು. So 0 ಯಾವಾಗ ಇರುತ್ತೆ, when force is 0 then work is 0, right? So when displacement is 0, then also the work is 0, right? So when cos theta is 0, then work is 0, right? So three cases. First one, so 0 work andre name itself it indicates 0. So work done namge 0 andre alli ಏನು ಕೆಲಸ ಆಗಿಲ್ಲ ಅಂತ ಹೇಳ್ತಾರಲ್ಲ, ಸೊ ಅದನ್ನ ಏನಂತ ಕರೀತೀವಿ ನಾವು 0 work. ಯಾವಾಗ ನಮಗೆ 0 ವರ್ಕ್ ಸಿಗುತ್ತೆ? ಫಸ್ಟ್ ಕೇಸ್ when force is equals to 0. So force ಅಷ್ಟೇ 0 ಆಗಿದೆ, so displacement is not equals to 0, right? Then also work done is equals to 0, right? So example ಇದಕ್ಕೆ an object sliding on the smooth surface, right? So ಯಾವುದಾದ್ರು ಒಂದು ಸರ್ಫೇಸ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಈ ಸರ್ಫೇಸ್ ಮೇಲೆ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಏನಾಗುತ್ತೆ ಸ್ಲೈಡ್ ಆಗ್ತಾ ಇದೆ ಅಲಾಂಗ್ ಹಾರಿಜಾಂಟಲ್ ಇರಬಹುದು ಅಥವಾ ಇನ್ಕ್ಲೈನ್ಡ್ ಇರಬಹುದು, ರೈಟ್? ಸೊ ಸ್ಲೈಡ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಇನಿಷಿಯಲಿ ಇಟ್ ಹ್ಯಾಸ್ ಸಮ್ ಪೊಸಿಷನ್, ಸೊ ಸ್ಲೈಡಿಂಗ್ ಮೀನ್ಸ್ ಇಟ್ ಚೇಂಜಸ್ ಇಟ್ಸ್ ಪೊಸಿಷನ್. ಸೊ ಸ್ಲೈಡ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಪೊಸಿಷನ್ ಏನಾಗ್ತಿದೆ ನಮಗೆ applying some force onto the object, right? So if you are pushing or pulling the wall, right? So if you consider this one as one wall, so you are applying some force. So ನೀವೇನ್ ಮಾಡ್ತಿದ್ದೀರಾ ವಾಲ್ ನ ಪುಷ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ. ಸೊ ಪುಷ್ ಮಾಡ್ತಿದ್ದೀರಾ nothing but you are applying the force, but wall ಏನಾಗಲ್ಲ ನಮಗೆ it does not displaces its position. ಇದೇನಾಗ್ತಿಲ್ಲ ನಮಗೆ ಪೊಸಿಷನ್ ಚೇಂಜ್ ಆಗ್ತಿಲ್ಲ. ಸೊ ಪೊಸಿಷನ್ ಚೇಂಜ್ ಆಗ್ತಿಲ್ಲ ಅಂದ್ರೆ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಏನಿರುತ್ತೆ ನಮಗೆ 0 ಇರುತ್ತೆ. ಸೊ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ 0 ಇದ್ರೂ ಕೂಡ ನಮಗೆ ವರ್ಕ್ ಏನಾಗುತ್ತೆ 0 ಇರುತ್ತೆ, right? So this one is the second case. So when work is 0, when force applied on the object is 0 ಇದ್ರೂ ಕೂಡ work 0 ಆಗುತ್ತೆ, right? So ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ರು ಕೂಡ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಆಗ್ತಾ ಇಲ್ಲ ಅಂದ್ರೂ ಕೂಡ ನಮಗೆ ವರ್ಕ್ ಏನಾಗುತ್ತೆ 0 ಆಗುತ್ತೆ, ರೈಟ್? ಸೊ ಆನ್ ದ ಥರ್ಡ್ ಕೇಸ್ ಇಸ್ ಫೋರ್ಸ್ ಕೂಡ ಆಕ್ಟ್ ಆಗ್ತಿದೆ, ದಟ್ ಮೀನ್ಸ್ ಫೋರ್ಸ್ ಇಸ್ ನಾಟ್ ಈಕ್ವಲ್ಸ್ ಟು 0, ನಥಿಂಗ್ ಬಟ್ ಫೋರ್ಸ್ ವಿ ಆರ್ ಅಪ್ಲೈಯಿಂಗ್. ಸೊ ಅಪ್ಲೈ ಮಾಡ್ತಿರೋ ಫೋರ್ಸ್ ಗೆ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಕೂಡ ಇದೆ, ರೈಟ್? ಸೊ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಇಸ್ s is not equals to 0, right? So but also work done is 0. So force act ಆಗ್ತಿದೆ, ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಟು ಆಕ್ಟ್ ಆಗ್ತಿದೆ, ವರ್ಕ್ ಡನ್ 0 ಇರುತ್ತೆ. So when cos theta is 0, so cos theta ಯಾವಾಗ 0 ಇರುತ್ತೆ? So angle between the force and displacement is 90 degree, right? So force ಮತ್ತೆ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಎರಡು 90 ಡಿಗ್ರಿ ಇದ್ರೆ ನಮಗೆ cos ವ್ಯಾಲ್ಯೂ ಏನಾಗುತ್ತೆ 0 ಆಗುತ್ತೆ. So 0 into f into s, again we getting the work done 0, right? So ಅದಕ್ಕೆ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಅಂದ್ರೆ if a person carries a load on his head or in his hand, so ಯಾವುದಾದ್ರೂ ಒಂದು ಲಗೇಜ್ ನ ತಲೆ ಮೇಲೆ ಇಟ್ಕೊಂಡಿರಬಹುದು ಅಥವಾ ಕೈಯಲ್ಲಿ ಇಟ್ಕೊಂಡಿರಬಹುದು. So force is acting normal. So contact force between the head and to the object. So contact force ಯಾವಾಗಲೂ ಏನಿರುತ್ತೆ ನಮಗೆ perpendicular direction ಇರುತ್ತೆ. So he is walking on a road, horizontal road ಅಲ್ಲಿ ಅವನು ವಾಕ್ ಮಾಡ್ತಿದ್ದಾನೆ ಅಂದ್ರೆ he changes its position. So somewhere here he will reach after certain time. So ತಲೆ ಮೇಲೆ ಲಗೇಜ್ ಇಟ್ಕೊಂಡು ಡಿಸ್ಪ್ಲೇಸ್ ಆಗ್ತಿದ್ದಾನೆ. ಸೊ ಇಲ್ಲಿ ಫೋರ್ಸ್ ಇದೆ, ಜೊತೆಗೆ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಕೂಡ ಇದೆ, ರೈಟ್? ಸೊ ಫೋರ್ಸ್ ಅಪ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇದ್ರೆ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಅಲಾಂಗ್ ಹಾರಿಜಾಂಟಲ್ ಡೈರೆಕ್ಷನ್, ರೈಟ್? ಸೊ ವೇರ್ n is also the force, so displacement. So here angle is pi by 2, that is 90 degree. So substituting here we get w is equals to fs cos 90 degree. So cos 90 degree value is 0, so hence w is equals to 0, right? So these are the three cases in 0 work. So 0 work ಅಲ್ಲಿ ನಮಗೆ three cases ಅಂದ್ರೆ three possible cases when force 0 ಆದ್ರೂ ಕೂಡ work 0 ಆಗುತ್ತೆ, displacement 0 ಆದ್ರೂ ಕೂಡ work 0 ಆಗುತ್ತೆ. So angle between force and displacement perpendicular ಇತ್ತು ಅಂದ್ರೂ ಕೂಡ work ಏನಾಗುತ್ತೆ ನಮಗೆ 0 ಆಗುತ್ತೆ, right? So nature of forces ಅಲ್ಲಿ ನಮಗೆ ಇಂಪಾರ್ಟೆಂಟ್ ಅಂದ್ರೆ maximum force W maximum that is equals to Fs, W minimum that is equals to minus Fs, and work that is equals to 0. ಸೊ 0 ಇತ್ತು ಅಂದಿದ ತಕ್ಷಣ ಇದು ಮಿನಿಮಮ್ ವರ್ಕ್ ಅಲ್ಲ. ಸೊ ಇದಕ್ಕಿಂತ ಲೆಸರ್ ವ್ಯಾಲ್ಯೂ ಇದ್ರೆ ಅದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ, ಮಿನಿಮಮ್ ವರ್ಕ್, ರೈಟ್. ಸೊ ಮ್ಯಾಕ್ಸಿಮಮ್ ವರ್ಕ್ when it lies between 0 less than or equal to theta less than or equal to 90 degree. Not equals to, it is less than 90 degree, right. So work is minimum when 90 degree less than theta less than or equal to 180 degree. So this is the case when f is equals to 0 or s is equals to 0 or theta is equals to 90 degree, right. So these three important cases. So this is all about the work done. So work done ali. So now we can study model definition, so important relation, so and the nature of the work, positive, negative or zero work, right. So next class we will start with the energy. So next class ali energy discuss madona, right. Thank you.